Hi, my name's Adam, and welcome to today's webinar on using REST and UI techniques to test a modern web application. In today's webinar, we'll be talking about how a modern web application is structured. We'll look in depth at the page lifecycle of a web application. We'll look at the different testable areas that make testing easy, and then we'll put together a recommended test strategy that blends a mixture of testing the DOM browser using REST web services and also specific techniques for the Ajax framework. We'll look at a list of practical tips and tools you can use, and then we'll have a Q&A. And the takeaways you should get out of this webinar, either if you're live on the phone or if you're listening to it recorded on our YouTube channel, would be, first of all, even if you're a tester and not involved necessarily with web development on a day-to-day basis, understanding how a web application is put together. What are the different architectural tiers and the layers, and how does that influence how you can look at testing it? We'll also talk about the benefits of combining UI testing and REST testing, web service testing. People will often think you should do one versus the other, and I think we're going to talk about why there's a benefit of doing actually both. And then lastly, the takeaways will be some tools and techniques that we have found and our customers have found at Inflectra are useful in testing both web interfaces and web services. So to get started, the first thing we should understand is if we're going to test a web application, it's probably a good thing to understand how does a web application actually work. And this has evolved over time. So if we start out at the sort of the highest level, this is your typical three-tier or often called N-tier web architecture. And what you typically have is a web browser at the top, which is Firefox, Safari, Chrome. In the old days, it might have been, IE, Netscape. And ultimately, that communicates over HTTP or HTTPS over the internet with a web application server or a cluster of web application servers. It can be more distributed or depending on the type of application you're running. But ultimately, there is a web application server that's serving up content to the web browser in some fashion. And we'll talk more about those two elements a little bit later on. There's also, in most cases, a database server that connects to the web application server, giving you your third tier. And that can be both a relational database that's giving you highly structured transactional database, or it could be a NoSQL or object storage, file storage, things like S3, basically storage repositories that give you unstructured data as well. So a database server in this case doesn't just have to be relational databases, it could be an unstructured data store as well, JSON files, XML, that kind of thing. Basically where your data is stored. And so we're going to zoom in on the client and the web application server for today's conversation. And so if we zoom in on that and go a little bit deeper, what we'll find is inside of a web browser, there's something called the document object model. And the document object model is basically the document that you have behind the scenes when you look at a web page. You see a visible web page. What the web browser is seeing is in fact a set of tags like this with a HTML tag, a head, a body, titles, content, and that's what ultimately makes up the displayed web page that you're seeing. That's the DOM is the representation inside the browser. And if you ever click F12 in a web browser and you see the developer tools, you get to see what the page that you're currently looking like looks like. And just try it on any website you're on, hit F12, you'll see the DOM, and that shows you what the page is that represents the visible page you're looking at. Okay, so, and then what does the web application server do? Well, there's actually a web server and an application server, and they're all in this yellow box together. And typically the web server part is serving out static HTML content. It's serving out that document. So if you imagine the item on the right is a document that contains all those tags, the web server part sends that over HTTP together with any other static content like style sheets and CSS and images and things like that that aren't necessarily going to change frequently. They're being served by the web server to your browser, where it gets turned into this document inside the browser called the DOM. Now, that's very good for brochure websites. Very quickly, people wanted to be able to have dynamic websites. And so what you'll typically do is then supplement that with dynamic content. And on a traditional non-Ajax website, on the web server, there was typically another portion of it called the application server, though it's often one thing. And that's responsible for taking the data from the database and taking your HTML, which might just be a template rather than a complete document, populating that with the content and then sending that combined data plus template in a dynamic form turned into a document sent to the browser. Now, as far as the browser is concerned, it doesn't necessarily know if that's a dynamic document or if it's a static content. As far as it's being considered on the browser, it's just getting a document, an HTML document that's a full document from the HTML tag at the top to the bottom with everything fully populated. Whether that's a static file on the web server or is it in this case a list of products that's been populated from a database, the web browser is agnostic to that. It's just getting a document. And that's a really important part of a traditional non-Ajax web application. The browser gets the whole document every time. Every time you click on a link or click on a button, it's getting a new document every single time. So the problem with that, if you're familiar with this with the environment, is that it makes pages very slow to load. It means every time you do even the smallest action on a page, it has to load a whole new document, reloading the whole page. It doesn't give you a very immersive experience. And so very quickly people realized that there was a better way to do things, and that would be to have the web browser but basically act as almost like an application rather than just a document reader. Because originally the web browser did come from the idea of it being hypertext and it being an information source rather than an application engine, which of course is where the web has evolved to today. And so Ajax programming lets you break that model apart and actually turn the browser into essentially an application itself. So what do we have now? Well, so the starting point is the same. We have a web browser and it has a document. And that document in many cases might just be the outer content. It might be the header, the footer, and the layout. But the content inside of the application is no longer being sent as a document. Instead, what happens is the web browser will make requests, these HTTP requests you see here, to a web service or REST handler, as we call it. And that REST handler, instead of sending back a giant HTML document, which is a mixture of the presentation and the data, it's going to send back something like this on the right, a list of data. So in this case, it's a list of products. So whereas before, you had this all mixed together, the products, the header, the footer, all of the content, you now have a list of books in a format. It could be XML, it could be JSON. This is JSON because it's a bit smaller to put on the page. And it's also more lighter weight for transiting over the internet. And so you can see here, it's a product with an ID and a name. We're no longer sending huge amounts of data. Every time you update the page, we're just sending a serialized list of data elements. And they could be very small. For example, you click on one thing, it just gets back one name or one tooltip. It can be very, very small, or it can be a giant grid of data. That's really up to you. But the point is that the page is no longer being sent as a complete document to the browser. Instead, the browser gets the document page, and then it makes secondary and third requests asynchronously, hence the Ajax, asynchronous JavaScript, and it gets the data asynchronously, and then that data that comes back, this JSON data, is then turned into HTML, into the browser DOM, by some kind of JavaScript framework. And it's basically a bunch of JavaScript that reads through these lists of products and then takes that content, turns it into visible presentation, so it turns it, let's say, into a table or a list, depending on how you want to see it, and then injects that list or that table into the browser DOM as a complete fragment. And that really is what Ajax does. So that's very much a traditional kind of Ajax approach. And if you look at how the web has evolved, the Ajax sort of movement has evolved over time with more and more sophisticated libraries. And if you were doing the first generation of Ajax, maybe 5 or 6 years ago now, the tools you'd be familiar with would be things like jQuery, which is still around, but probably isn't used quite as much as it was. There were some frameworks that were more sophisticated in terms of what they offered. They offered templating and data binding, things like MooTools, Prototype.js. There was the Microsoft ASP.NET Ajax framework, which ships with some of the early versions of web forms, but is now not really used a lot for new development. There's also things like from Sencha, XJS, and then Yahoo and Google had their own first generation frameworks called YUI and GWT. And these frameworks really focused on trying to take some of the complexity out of Ajax programming, giving you things like data binding, web service handling, cross-browser simplification, so the same thing would work in multiple browsers, and templating and state management. Many of those frameworks, unless they're no longer in use, probably the only ones you're going to see now might be jQuery or XJS or some of the ASP.NET stuff. But then a second generation of frameworks came along, and they fall into two main groups. There's the groups like AngularJS, which are very big and comprehensive and let you write an entire single-page application. And then there are some other frameworks like Knockout and Backbone, Ember, Mustache that are very focused on specific problems. For example, Knockout is designed to solve the data binding and templating problem, and that really is all it does. It doesn't handle much of the rest of it. So you using something like Knockout, you're going to have to use it plus a bunch of other technologies. And then the latest generation are things like React and the new version of Angular known as Angular 2 or Angular without the JS, and things like Vue. And there's probably new tools coming out all the time. So I'm sure by the time you watch this video, you'll be seeing many tools that I don't even have on here. And that's very typical. One of the challenges is always going to be in development is how do you keep up with all the tools, and you can't constantly be rebuilding your application just because a new tool came out. So I think you have to look at your application, look at how long it's going to be around for, look at the technologies, and make a choice that maybe will last you for 5 years. And I know that within 5 years you may have to rewrite some of it and refactor some of it. So what do these new frameworks give you? Well, in many cases, and it does depend on the framework, of course, they give you some new features that try and make Ajax programming easier and more modular and take out some of the complexity. And also one of the challenges is performance and memory leaks. Some of the things that if you're writing your own set of Ajax calls in JavaScript, it's easy to make mistakes and have an application that works well on a test environment, but when you throw lots of data at it, it can be very slow and buggy. So what React does, first of all, is React is a relatively new framework from Facebook, and it lets you take this Ajax monolith, these set of JavaScript libraries that you might have, and instead think of it in a very modular form. So what you do is you have these things called ReactJS components, and a component would basically be something like this. So let's say we build a component called a table, or maybe it's a more specific component like a product table, or a tree view, or a customer list. You can make them very specific or very general depending on your application. And what you'll do is you can define, it's very much like object-oriented programming, where you can define a component like a table, and it can have properties, it can have state, it can have operations, and all the logic around how to turn the data from the web server, the JSON product data, let's say, that we saw before, and turn it into something viewable. That one component can be used across your application. So if you want a sortable grid with filters, sorts, maybe it's got inline editing, you can write a React or buy a React or get an open source React component that would do all of that for you, and you can use it throughout your application versus having to have JavaScript on every page that's different. So the great thing is it does let you centralize your presentation logic, making it guaranteed it's going to work the same way across your entire application. The other thing that's quite interesting is it has what's called a virtual DOM, which is unique to React. And so what that does is React, instead of just writing its output, so React, like this table, will take your list of products. So this is the table component. Let's say you've got 10 products. It's going to turn that into an HTML, say, table or list with 10 rows for each of those products. Rather than writing each one to the DOM, the real browser DOM, it actually maintains its own shadow version called the virtual DOM. It manipulates the virtual DOM, and then when it's ready, it then pushes that whole DOM as a copy into the real browser DOM. And this gets by some of the performance issues in browser applications where every time you change the DOM, the page has to reload. It's called reflowing, and it slows down the application. So it's a neat thing they've added, which really improves the performance of React-based applications, and it's pretty cool. So that's a React application, and again, this is not a programming webinar, so I'm not going to spend too much time on it. The other thing we have is Angular, which is another framework from Google in this case, and Angular is good in that it has a lot of pre-built functionality in terms of laying out your page, how to structure your whole application. It's a bit more all-encompassing, and I must admit I'm not as familiar with it as with React, but the way it works is written in TypeScript, which is a typed version of JavaScript, which is nice because it gives you some compile time checking, type checking. So it gets around some of the issues in JavaScript where you don't know there's an error till you run the application, which is nice. And it uses TypeScript together what are called templates and modules and services. And it will take the data and it lets you build out a template like this here. We've got a table and we're looping through a list of products, and we turn that template turns that JSON set of data together with this TypeScript component. And we put these components and these templates come together, and they will render out the content into the DOM. And so the nice thing is you've got templating, which is in an HTML format, which is nice and easy for people to understand. And then you have the logic in the JavaScript or TypeScript component. So this is good because one of the challenges of JavaScript programming is you don't want all the presentation, all the HTML tags, buried inside of your JavaScript, and you don't want all your JavaScript necessarily embedded in your page. So it has a nice separation of the two, so it makes it easy to maintain. And that's one of the other things the newer frameworks try and do, is not only make the system easy to code, but easy to maintain. So that's kind of how these applications work. So you may ask, as a tester, why do I care? I mean, it's just a web application, it's just a browser application. Should I care that it's React? Should I care that it's Angular? Well, in some ways you might care, because some of these newer frameworks actually make it harder to test, because if you look at a typical React application, unless you are careful as a programmer, there's not a lot of IDs on the elements, there's not a lot of attributes. They can be very attribute light, and that makes testing much harder, because there's less things for the like Selenium or another tool that's using web testing for UI testing to lock onto, because there's just less unique attributes, and that is a big challenge. So it's going to impact you one way or the other. You can certainly do things in React or Angular or any framework to make testing easier, assigning unique IDs, stable IDs, things like that a developer can do to make a test easier for the tester. Obviously, sometimes you'll get applications that you have no control over. They're written by a third party, or they're commercial or off the shelf, and you just have to test them. So what can you do to make testing easier? So the first thing is, let's look at what we could test. So the simplest thing we could do was we could just test that JSON data. So if you remember, there was a list of products, an array of products in JSON. We could receive what came back from the web service. We could send in a request to get a list of products. We could do post operations and send data. And so there's definitely testing we can do there. We can also look at the browser, what's visible on the page. Well, that's very good, because that's obviously what the user is going to see. The other thing you could test would be the JavaScript framework itself. And this is a bit more advanced, where somewhere in between the other two, can we use the fact that we're using React to write some specific things that will test it at different states? So we're basically doing some testing inside of React, as opposed to waiting for the browser to get it. We're waiting for the browser DOM to get it. It's still in the browser ultimately. And in this case, we're going to focus more on React, just because, again, I know it better, but the same concepts are equally applicable to Angular. There are frameworks for both, for testing. So let's look at why we might test one or the other. So first of all, let's look at JSON data. So if you imagine there was that list of products that we had back, it's very well defined. It's a data structure. It has to be defined the way that the web service expects it, and we have to send the data to it. So the good thing is, we write a test for this. We know it's going to be reliable over the longer term. It lets us do some unit testing of key modules. So I can write a product testing module that will test the list page, the way you can list the products. I can write a unit test of an edit page where you send a product, make a change, post data, get it back. So it's very, very modular. You can test each module nicely. The other nice thing is it's really fast. These tests run really quickly. You're not waiting for the browser to do anything. You're just sending data to and from a web service, and those are designed usually to be high availability and high response and high performance. So if you're doing CI level testing every time the build runs, and you're doing some smoke tests, it's probably a good thing to do some of these, because obviously it's going to be very fast and reliable. And the other nice thing is, it doesn't matter what browser you're using. The latest version of Safari or Chrome makes no difference. This is just data we're dealing with. But those advantages do come with some disadvantages, naturally. The first thing is, it doesn't test the user experience. So just because the data came back doesn't mean the user saw it, doesn't mean the user page works. And when we're talking about programming and architecture, there's always this thing that, well, the business logic and the validation, everything should be done server side, and we should assume nothing on the client side, and that's all well and true. But in the real world, because in the end you want an application that's going to be fast for a user, it's going to make the user experience easy to use, you will perform some business logic and some validation inside the browser. You might have to replicate that on the server just to make sure it's not tampered with, but from a user standpoint, if you're looking at flights and you want to make sure the combination is valid, it's very frustrating to go all the way through a wizard and then told you can't do something. You want to give feedback to a user as quickly as possible. Inevitably, the client side has to be tested, and just testing the JSON data does not mean the user is going to get a good experience or a working experience. And it doesn't really validate how the thing looks, because obviously this is just data. It can be displayed in a number of forms by the JavaScript framework. Just because the products themselves look good doesn't mean they fit on the page, doesn't mean they appear correctly in different languages if the browser's language changes, doesn't test how anything looks or renders on different size devices. So for these reasons, it's not really a good test of what the user is going to see. And as we always say, if you're not testing it, the user is. And we don't want our users to be our testers. So at the other extreme, and this is where most people I think spend their time with web testing, is testing the DOM, which is let's look at the web page. We have to test that anyway, either manual or an automated fashion, because that's what the user is going to see. So we'll test the final DOM, we'll test the final web page. We'll guarantee that what the user sees is what the user gets. The great thing is this will help to find out where it breaks down by the browser, because even though the browsers all should work the same way, they unfortunately they don't. And so just because something doesn't work on Safari, that's a really big issue if you're pushing your application out to Mac users or people using Safari on iOS devices. That's going to quickly cut down your market share really quickly. So it's really important to make sure you know how does something perform on the different browsers. And even if you don't support IE10, maybe you know that some people in your user base will use IE10, can it degrade gracefully in a way that still lets them do some of what you need them to do. The other thing it will let you do if you test the final browser is it will let you test for usability and performance, responsive design for different devices too. These are things you can only test really in the final product. The big problems with browser testing, I'm sure people know if you've done a lot of Selenium testing, is that you can really only test a flow through the application. You can't test bits of a page being built up, only the whole thing. So that can be a problem. So if there's a problem somewhere, you only can get it when the whole page has been rendered. If there's an interaction that's strange between different components on the page, maybe they're loading in the wrong order, it can sometimes be hard to isolate what's going on. So it makes it therefore hard to debug. So when the test fails, it can spend a lot of time trying to figure out why it failed, not just that it did fail. And therefore it's also hard to test specific pieces in isolation. And then unfortunately, changes in the DOM, even things you aren't intending to change, will break the tests. So for example, if you have app attributes in the web page that change frequently, there's a good chance that even if you write a good test, it might break. If you have an application that has very little stable IDs and you're relying on the third row of the second column and the first table, it's very easy to write a test that as soon as it's written will break within days. So changes in the web page layout, changes in the naming conventions, changing in the attributes, changes in what's visible on the browser. You may have hidden parts of the browser. Maybe you have different layers that appear and they're just hidden, not deleted. It's very easy to write tests that break really quickly, and even writing good tests takes quite a bit of skill. So that's the rendered DOM. So what else could we test? Well, this is now when we get into something that's specific to React. Could you test the React virtual DOM? Well, the answer is yes, you can. And why would you want to do that, though? Because it's still the DOM. Why not? What's the benefit? Well, the benefits are you can test pieces of the page without testing the entire page. You can also test that the browser DOM is correct without testing that the browser is correct. And what I mean by that is if you want to test that your list of products is turned into a table of products with TRs and TDs, and that they have the right IDs and they have the right values and they're in the right order and the right columns are being displayed and the wrong ones are not being displayed, you could do all that testing inside the React virtual DOM, and you wouldn't have to worry about how the browser's doing it. If the browser's doing some strange things where it's ignoring tags or doing some strange things with how it rendered the DOM, you take that piece out. You can also test it directly as the React library builds up the page. You're testing it at exactly the same time, so it's really fast. Unfortunately, there are some problems with testing this. Nothing is for free. It doesn't reflect what the user is going to see. So just because you had a list of products that turn into a table, now you have tested it does turn into a table. That's good. And you test that your React component worked and was able to render it into a table. Doesn't mean that the browser saw the table correctly. Doesn't mean that it's displayed correctly. Doesn't mean it's visible. Doesn't mean it looks good. Doesn't mean it fits on the page. Doesn't mean the user can do anything with it. Doesn't mean that it loaded fast. Doesn't mean that the user can interact with it in a reasonable way. So it's not perfect, but it is a useful way of testing how something renders without having to test the whole page. And then the last thing we can think about is testing the component state. This is, let's just test not how the thing was rendered, not the list of products, but somewhere in the middle. Can we test the business logic? Can we test that if you add a product with a negative price and hit save, before you try and send it to the server, that the React component correctly validates it? If you use a comma instead of a period for your decimal point, because you're in some parts of Europe, will it work? Will it throw an error? Do you need to worry about that, for example? So you can do a lot of testing by hooking into the state of the components themselves, both for rendering and also for interacting with users' actions. And the great thing here is that you're able to do testing before it gets sent to the web server. You're able to test the user experience from a business rule standpoint, validation of data. You can do a lot of really important tests that you do need to do, but you don't have to rely on the browser being updated. You have to rely on the IDs on the page, it being visible. It doesn't test the end user experience, but it does test some really important things that are quite hard to test and complex to test if you try and do it in the browser DOM directly. So it takes some of the ability of doing unit testing and pushing it into the browser. So that's really the four options you have for a React application. And in terms of Angular, there are some similar options around the templates and the components, which I haven't shown. You can do those as well. So let's look at the what we call the test coverage, because one of the things we want to talk about is which should we do. And this is what we would consider, at least we would recommend this as being the diagram that's really helpful. And if you have to think of one diagram from today's presentation, this is kind of the killer slide, which is the test coverage. You can't now, in a world with infinite time and infinite resources, you would say that all these lines, these orange lines, should be to the right. I mean, you certainly should write unit tests on your server-side code. If you're writing in C# or Java or Python or Node.js, anything on the server side needs a good set of unit tests and maybe even some functional tests. Anything you can test on the server is great because it's faster to test. It can be tested as part of your build. You can do test-driven development. You can do behavior-driven development. That's just table stakes, to be honest. You need to have that. Then you can look at things like, well, should I have REST tests? Should I have UI component tests? Should I test the virtual DOM? Should I test the browser DOM? You could test all of these or for every single function, every use case, and in which case all the lines would be to the right. But recognizing that there aren't infinite resources and there isn't infinite time, we have to basically have a trade-off between what we call resilience and realism. And that's what we call this on this axis. And so this is the breadth of testing you should do, and this is basically at the top. The further up the top of this chain you go, you get to test the more realistic. So testing the end user's browser is the most realistic thing there is because that's what the user is going to be using. Similarly, doing a set of server-side unit tests is important. It will test the application, but it's not particularly realistic because the user isn't running a unit test framework. They're interacting with an application that calls a web service that calls your unit tests, that calls your server-side code, I should say. So again, on this spectrum of resilience to realism, the ones at the bottom are more resilient. Everything at the bottom is going to be more resilient to change. It's going to be a test that you will write once and maybe change every 2 or 3 sprints, as opposed to potentially having to change every sprint, every time you change a page. And so you need to look at your test coverage and see, if I can only spend 20% of my time doing end-user browser tests, which pages should I test? Knowing that I'm only going to spend 20% of my coverage on that, only 20% of my use cases I'm going to do that for, well, if I can do a virtual test on some of the virtual components, maybe if I write a test for our tables and our tree views and our list components, maybe I'm both testing the components and maybe testing the virtual DOM it renders. If I wrote those in React, well, now I can save a lot of time on my browser's testing because I know that every table and I know that every tree view works correctly, intrinsically. I don't know how it looks on the page, but on some of the bigger pages, I want to do a browser test, make sure that they all work well together, but I don't have to worry that on a simple page, they work on their own. So that way you reduce the amount of time you have to spend doing a browser test if you know that all your components work together. It's the same way that if you're building an assembly, if you test the components and the parts and the assemblies and then the whole thing, you haven't got to test the whole thing as much. It's classic engineering. So again, looking at this hierarchy, make sure you're spending enough time. Too many people, I think, will spend time doing these unit tests and then jump straight to some Selenium calls. They miss out all the middle pieces. Make sure that you take some of the time that you would have spent doing browser tests and write some REST calls, write some component tests, or test the virtual DOM if it's React. If you're not doing React, if you're doing something that doesn't have these virtual DOM or components that are well defined, still have browser tests, test the web services exhaustively, test the server-side tests exhaustively, and maybe there's even things you can do in your Ajax framework. Even if it's not one of these frameworks I've mentioned, maybe it's one of the older ones, that still doesn't mean you can't do testing inside the framework. You could write stubs, you could write hooks in, callback methods, things to make the test more easily. So we have some sample applications which we have on our website, which you're welcome to look at. First of all, one is our website. So our website, if you look at our pricing page in Inflectra, we had this page to test, and one of the challenges we had was that it's a page that has lots of dynamic data. You can look at the products, you can choose between cloud and download. You can check on all the prices, and we've done some web tests using our UI testing tool. But we also recognized there was a lot of JSON on this page that could be tested. So we wrote some JSON tests that would pull back the list of products. It would pull back the list of editions of each product, and then the list of cloud versus download. And we found that by doing that, we were able to have a much higher test coverage because it's just a simple hierarchy: product, cloud versus download, and an edition. It's all JSON data, and we could do some very simple testing where we would fire a request for every one of these combinations that you see here and get back the data and make sure it was correct, as opposed to having to click on every single one of these expanders, click on every single one of these tabs, and then click on every single one of these items in each tab and verify what appeared on the page. We did that for some cases, but certainly it was much easier to do that for the page using some REST tests, and then just do one simple use case to make sure the thing looks okay. Another application we'd recommend you look at is our sample React application. This is a version of our built-in library application. It lets you log in using a login and password, which is a good test. It lets you look at a list of books, a list of authors, and it lets you create books, create authors, edit them inline. So it's a good CRUD test where you can create, read, update, and delete items, and you can do it both through the JSON data and you can do it through the React. And we do provide the source code of these applications. If you want to take the application and actually write some code in it to extend it, or just simply hook in some unit tests, you can do that really easily. It's just on our GitHub channel. We also do have an Angular test as well. So if you want to play around with Angular, feel free to take our Angular test as well. That's on our website. So that's some of the technique, that's some of the framework and the strategy around how you would go about doing these tests. Well, the next thing will be, well, that's okay. So I'm going to test my browser. I'm going to test my unit tests. I'm going to test my JSON web services. I'm going to do some testing of React, and I'm going to do some testing of my components and my virtual DOM. So what do I use? Well, you could build it all yourself, or you could use some tools. And in this list of tools, we've got a mixture of commercial tools and a mixture of some free tools. So first of all, let's look at REST testing. We're going to test web services. We want to test the JSON or XML data going to and from the web server. The cheapest option is probably Postman, which is a free tool. There are also some tools like SOAP UI, which are both commercial and open source. There's a SOAP UI and a SOAP UI Pro, which you can use. There's also our own tool, Rapise, which I'm going to push here. That's an integrated tool that can do both REST testing and UI testing. So that's a nice option if you want to use the same tool and the same framework for testing the web services and testing the user interface. So that's another option, especially if you're already a customer of ours and you are using it. Feel free to use the REST testing portion of it to increase your test coverage. The tools I've also found are VREST, Parasoft, and Groovy. There's some newer tools that I haven't as much experience with. Parasoft, a really good vendor if you want to do really, really powerful API testing with synthetic data, with the ability to mock up the data coming to and from different services. So if you've got a very complex application where you've got different websites interacting with real-time data, you need a fake bank that integrates with a fake broker. Parasoft has some really cool tools to do some of that. So if you're doing more than just basic UI, API testing, definitely look at Parasoft. Otherwise, VREST and Groovy are two other free tools that are out there that could be useful. For testing the browser DOM, obviously, Selenium, aka WebDriver, is the number one that everyone's using. Lets you use your language of choice. It's really flexible. It lets you write in code pretty much anything you want to do with the browser. If you want something that's a bit more user-friendly and doesn't require you to code everything by hand, there are some good commercial tools. The three that I've used are obviously our own tool, Rapise, which we use a lot, Ranorex and Test Complete, which we also have customers using with our test management solution. We've seen them both and used them both. They're both relatively inexpensive and relatively easy to use also, so I would also recommend those if you want something that's moderate. If you want to spend a lot of money and you've got some very complex needs, the three kind of tools you might want to consider would be Tricentis Tosca, HP UFT, known as Quick Test Pro in the former life, and then Squish. And if you're doing a lot of cross-application testing, so not just web apps, but also doing things like Qt and Java and mobile apps, Squish is an interesting one that might be worth looking at. So those three at the bottom are the more high-end tools. The three before that are your mid-price tools, and then Selenium is kind of your free option. And these are all good tools for testing browser DOMs. If you've got a very simple browser application, probably just use Selenium. If you've got something complex like Microsoft Dynamics or Salesforce or SharePoint, something where you've got lots of complex grids and tables and tree views and things like that, then the other tools, the commercial tools, may save you some time, but it's up to you. And then when you're looking at the framework-specific tools, I've put these into the two different frameworks because they are very different. So if you are using React and you want to test the component state, then the tools that we've come across that people say are good and we've used ourselves would be testutils is the framework, and then the different runners you can use would be Jasmine, Jest, or Mocha. Mocha and Jasmine are used beyond just React. They are just general Node.js or JavaScript runners. But if you're using with testutils, that can tie into the component state. If you're testing the virtual DOM, then you can use the Mocha runner with a tool called Enzyme. So Mocha would be a common runner you could use for both the components and the virtual DOM, and then you could use the different frameworks for plugging into it, testutils or Enzyme. For Angular, if you're testing the service parts of Angular, then Jasmine and Mocha are pretty good runners you can use. They can work with JavaScript in the browser as well as Node.js. And then if you want to test the components inside Angular, obviously you can do it yourself, but there is a thing called TestBed, which is a tool that lets you hook into the components more easily. They've done some of the hard work of doing that, and that works for both Jasmine and Mocha. So whatever you're using to test the Angular services part of it, you could also use with the components piece as well. So whatever you're using for one, just use the other one, that for the other, and add in TestBed, and you're good to go. So that's basically our webinar today on how you would test a modern set of web applications. And as I mentioned at the beginning, web applications are pretty hard to test. They're typically harder in some ways than mobile or desktop apps because there's so many different layers inside the application. The DOM is hard to test. There's lots and lots of pages and lots of state being held within them. They're typically larger, more controls, more data than a mobile app, and also the DOM tends to be trickier to test than, say, a desktop app. And unfortunately, you do need to understand the application you're looking at. It isn't really enough just to look at a web page and say, I'm going to test that without knowing how it works. It is worth spending a little bit of time understanding how is this specific application put together. Is it using Ajax? If so, what flavor of Ajax is it using? What frameworks is it using? Is it sending data through XML, through JSON? How is the page state being managed? If you have the development in-house, definitely talk to your developers, find out what they're doing, find out what they're going to be doing next in case they're going to change. If it's a commercial or open source or a third-party app, do some investigation, find out what it's using, how it's put together. It makes your testing much easier. And then the other thing is you can test all the layers of the application. That's not a problem, but some are easy to test, and some of them will make your tests break more quickly. Others are more resilient. So plan your effort to make sure you cover the most important cases in the most important tiers. Don't just try and automate every single web page, every single way for every use case. Be careful, be strategic, use your time carefully. Find out what elements are common, automate those, and then find out where they're used in different situations, and then find use cases where you can make sure you have the maximum test coverage for the least amount of rework. And that's really what you want to do. You want as much test coverage as possible with the least maintenance. That just makes your life much easier. Thanks for watching today's webinar. I hope it was useful. If you'd like to learn more about software testing and test automation, please subscribe to our YouTube channel.